Okay, second part of the video for today that just goes through the last example here. Now, I want you to notice right away with this example something you got to watch out for because it's really going to mess you up if you don't watch for it. It's got to be the first thing you check out in any polynomial example is to see if there's a common factor there. And common factoring comes up again and again all through all the grades, all through university, and you got to watch out for it. It's got to be the first thing you look for in an equation. And here there's a common factor here, and it does two things. One is it immediately takes one of the degrees off of this situation, and the second thing it does is it causes you to not mess up when you're doing synthetic division. If you don't bring that common factor off, it's easy to mess up and not put a 0 in as the last term. So here I immediately see that a common factor of x comes right off the front here. So I get x to the power of 4 minus 5x cubed minus 7x squared plus 29x plus 30. So isn't that nice? I mean, just for that reason alone, watch out for common factoring so that you know you've taken care of one of the degrees right off the hop. It'll also mess you up with the coefficients if you don't do it. But okay, so then to do the rest of the factoring, let p at x equal x to the power of 4 minus 5x cubed minus 7x squared plus 29x plus 30. And I try p at 1, sub that in. So it's 1 to the power 4 minus 5 times 1 power 3 minus 7 times 1 squared plus 29 times 1 plus 30. And I get 48. So we'll try p at negative 1. There it is. P at negative 1 equals 0. Therefore, x plus 1 is a factor. So I've got a k value of negative 1. Write down those coefficients 1, negative 5, negative 7, 29, 30. Bring down the first one. Multiply by negative 1. I get negative 6. Multiply by negative 1. I get 6. I get negative 1. Negative 1 times 1 is 1. Add them, I get 30. Multiply by negative 1, negative 30. 0. So happy when I see that 0 there. So we have the original factor of x, that x plus 1 I brought off, and now x cubed minus 6x squared minus x plus 30 equals 0. And then I'm going to let q at x. I know in the previous example, I just let them both equal to p at x, and I guess it's really no big deal, but technically speaking, you should probably give this a different name. So I'm going to give that, plug in a 2 there, so I get 2 cubed minus 6 times 2 squared minus 2 plus 30. I get 12. If you've noticed, I should have tried negative 1 again, because negative 1 white might work again. And I haven't forgotten about it. If nothing else works, I will try that negative 1 again. So now negative 2 cubed minus 6 times negative 2 squared minus negative 2 plus 30. There it is, 0. Therefore, x plus 2 is a factor. So, we have the original x factor, then x plus 1, then x plus 2. And what I have left over here is forgot to do the division there. K equals -2, coefficients. Bring the first one down, multiply by -2 and add, multiply by -2, 16 and add, multiply by -2. Oops, multiply by -2 is 16. Add, I get positive 15. Multiply by -2, I get -30 and 0. I knew that was a 0 had to come, so I knew when I didn't get 0, there was going to be a problem there. I just made a little mistake with the positive negatives there. And so what I get as my other factor was x squared minus 8x plus 15, which I can factor as x minus 3, x minus 5. See, once I get down to degree 2 factors, I just use my old methods. Two things that multiply to 15 and add to -8. And so therefore, now because this is 0 over here, I know each one of these factors, any one of them could be 0 to make it come out to be 0. No other number does that. If it was multiplied together to give 8, I wouldn't know what any of the numbers could be because lots of things multiply to 8. But if they multiply to give 0, each one could be 0. So that is what it's called the 0 property, and it allows me to solve these things by factoring. Because if x is 0, it doesn't matter what these other things are. It'll multiply it together to give 0. If x is -1, if x is -2, if x is 3, and if x is 5. Those are all my possibilities there. Okay? Let me do a little therefore. There we go. So points to ponder, why do we want one side equal to 0? So we know that each factor equal to 0 will be a solution. No other number on the right side does that. Notice we could have as many zeros as the degree of the function. In the last one, it was degree 5, so I got 5 answers. We could have that many. It might not work out that way. You might not find that many zeros. But what's the minimum number for odd and even degree functions? For odd degree functions, we must have 1 0. And it's because of the end behavior of odd degree functions. They have to go from negative, must have 1 0. If it goes from negative infinity up to positive infinity, somewhere along the way it must hit 0. And for even functions, no 0 needed. Think about a quadratic. A quadratic can start up at positive infinity, come down, not get to 0, and then go back up to positive infinity. So it must have 1 0. So think about this. Here's a degree 3. You see it's got to eventually go through 0, where an even degree function doesn't. And how can we solve polynomial equations that do not factor? Well, that's quite an issue, actually. If things don't factor, there are ways to solve them. Not everything has to factor. And what we would do is we'd do some studying of the situation. So let's say I went through a whole polynomial, couldn't factor it, but I did notice that p at 3, for instance, was 5, and that p at 4 was -2, something like that. And by looking at those two, then I could look and go, oh, somewhere between 3 and 4, there is an answer. And then I could break that down and try and get closer. And you'll see that in later calculus courses where we will break this down when it won't factor. For now, anything in grade 12 will be set up to factor, and we'll deal with these situations later. But our investigation, when we found a positive number and a negative number, we'd go, oh, there must be an answer between those two, and we'd use all sorts of different methods. There's all sorts of different methods to narrow that down once you've got those two. Okay. That was Solving Polynomial Equations, Part 2. A couple of notes at the end and a long example for you to look at if you're still having trouble with factoring. But listen, more factoring in tonight's homework, so get it all taken care of. Get your factoring skills right down pat, because